It is December 4th, 2007. I am Sonic Sons. I'm doing a video about general relativity and how I don't get it. Okay, so this is the deal that Einstein came up with, not the only deal, but a big one. So have you heard this thing that if you go near the speed of light, time slows down for you, and from your perspective, everybody else goes faster in time? Now, this by itself is pretty weird. I read The Universe in a Nutshell by Stephen Hawking. I can't pretend to understand all of it, but it was actually very fascinating. Even if you don't get it, you're like, wait, like it's half of a thought there. It's weird stuff. I think this is the biggest discovery of science in the last century, is that it turns out the universe is really, really weird. And then there's the relativity stuff, and there's the quantum stuff. And the quantum stuff, it's like, it's not even deterministic anymore. Like, as the current theory goes, you can't know where a certain particle is and where it's in its direction of movement at the same time. It's called the uncertainty principle. You can't know. It's like against the laws of physics to know that. Which is almost kind of scary. Quantum particles do these weird things where they like practically just like go from here to here without like passing through the space in between or something. Or like there's quantum entanglement, I think it's called, and you'll have like two things that are somehow linked to each other, and then even if you put them over a vast distance, when you observe one, it'll have this one property, and then the other one will instantly have the other property, which seems to be faster than light communication, unless somehow they have those properties already. And there's nothing with quantum mechanics. Apparently nothing is the way it is until you look at it. So it's pretty weird that way. Schrodinger's cat, I think one of them, I'm getting off of relativity now, but still, like, okay, the idea is from Schrodinger's cat, you put a cat inside this big, like, metal box that you can't see in, and there's no windows or whatever, right? And there's a little radioactive thingy, device, on the outside, which may or may not release a particle. And no one knows. The weird thing with some weird radioactive quantum type stuff is like you can't know. It may or may not release a particle. Now there's a device attached to it so that if it does release a particle, if a thing like detects a particle, it'll trigger this other thing inside the box, and it will release some poison gas and kill the cat. Poor cat. Now the thing is that before you look at the quantum particle, it is in every possible state at once. Like, it's here and there. Like, it exists and doesn't exist, or something along those lines, at the same time. Which means Schrodinger's cat is dead and alive simultaneously. Like, not even like there are two cats. Like, it cloned itself. That would, you could kind of get your head around that. But, like, there's one cat. And he's alive. And dead. How does that work? I don't know, it's not straight figuring this out. Okay, so, relativity, states, well, for one thing, space and time are apparently made of sort of the same stuff. It's called space-time. I couldn't think of a better name. So space-time is curved. And it curves around physical objects. So apparently, gravity results because when there is mass, the space-time curves around it, and this causes things to fall towards it, or something. Which is kind of weird. How is the space-time curve? They often show this in a metaphor where they'll have like a 2D like net, and they'll put a ball in it, and like the net will like curve around the ball, kind of. And you're like, okay, but how does that work in a 3-dimensional net? Do we have like a 4-dimensional ball then? Well, 4 if you count the time dimension. But time isn't even hardly a dimension anyway, because like you can't go backwards. So it's like a halfway dimension. Or whatever. And then there's these things with, like, I keep hearing these theories with, like, you know, they're like 12 dimensions or something. First of all, how did you come up with the number 12? Why not 99? Why not? I'm sure there's a very good reason. But it's okay, they say, because these dimensions are folded up. What does that mean? I can understand having multiple dimensions. This is one thing I have my mind around, is, like, if you take the metaphor of two-dimensional plane and two-dimensional people, and then imagine a three-dimensional object, like, walking through their thing. Well, they would see, like, this two-dimensional foot just appear out of nowhere, and then, if the guy is walking, then, like, it would disappear out of nowhere, and appear, disappear, you know. So, essentially, spatial dimensions greater than your own allow for teleportation. Essentially, right? The 2D people just see this thing, it's there, and it's gone. And then it's there, and it's gone. And it's there. And it's wherever it wants to go, and it's very confusing. So I can understand, okay, so there could be a fourth spatial dimension on top of our own. Okay, so that would essentially allow things to teleport, if we knew how to access it. And of course, the 2D people, they don't know how, and us 3D people, we don't know where this thing is. It's kind of weird, thinking if there's a fourth spatial dimension, like, where is it? Where is it? It's in none of these directions that you can possibly look. Because the 2D person, he's looking in every direction he can think of. He doesn't look up. But we're looking around and up, but the other fourth spatial dimension is somewhere else entirely. Somehow. Okay, I can wrap my head around that. What really confuses me is when they say, okay, but these other dimensions are folded up really tiny-like. I'm like, I'm sorry, how does a dimension fold? Like, what would happen if we took the Y dimension and folded it? What would that be? Fold? How do you fold? What is that? It's almost like saying, if we just fold up the planet Earth, like, how would you fold the Earth? What are you talking about? Even that would make some sense if Earth was, like, made of paper and you did some origami with it, but, like, folding a dimension? And they're very small. Oh, it's a small dimension. Right, we don't want a big dimension. I thought dimensions were infinite. What are you all talking about? Okay. So there's dimensions. I still haven't gotten into relativity. Okay. Twins paradox, right? Goes like this. You get two twins who are obviously the same age. One of them stays on a planet, and the other one gets in a spaceship and flies away at nearly the speed of light. After a while, he turns around, comes back, and the guy who was in the spaceship is now much younger than the guy who was on the planet. And I've heard this where they did this with, like, super accurate clocks, and they sent one this way around the Earth and they sent one that way around the Earth to change their speeds, and then, like, the clocks were slightly different. But then someone else told me, this one guy I know that actually knows all the formulas for this, and even he doesn't understand it. But this one guy told me, no, actually that's not due to time dilation because the near light speed, because obviously the plane is not, rather it is due to, like, the gravitational field of the Earth, which as it spins, it drags the space-time along with it, which is why you send up one plane according to the spin and one plane not according to the spin thing. Okay, fine. Time dragging stuff.